Hello and welcome back to the second video tutorial for Woodbee plugin. In this video, we're going to do our first example, and that is basically creating toolpath for the parts that you can see here. And as I explained before in our introduction video, the parts, all of them, they have to be a solid geometry, and they also have to be the same thickness, and they all have to be in the same plane. So in this file, I am also showing a vacuum table that we are using it in our workshop, and the parts are just laid down on this vacuum table with a certain offset, which is going to include those supports underneath. So we're going to open the Grasshopper now, and we'll look into Woodbee panel and then look for a component called planar sheet. So there are basically two different approaches in Woodbee to create a toolpath. One is that you start with this component, which automatically detects the features in your geometry and then gives you the proper operation for each feature type. The other way around is that you start with your operation or with your milling strategy just directly by creating them. But then you have to provide different type of inputs, uh, and then you need to know a lot of technicality behind this. So the easy way is to start with the planar sheet component, which only takes the geometry as a part, and the plane, which actually refers to the working plane. In this case is the plane of my table. It doesn't have to be on exactly on the table. It just has to have the same orientation as the top of the table. In this case, it's going to be an XY plane, but that's already by default. So what I need to do is just to take the geometries into Grasshopper by selecting one or multiple. The good thing about Woodbee is that you can run that on a multiple objects in the same time. It creates a composite toolpath basically that basically mills everything from the single sheet. So now I'm giving the geometry into the part input. The other essential input is the tool, and without a tool, this component won't work. A tool in Woodbee has basically two parts. Under tools, you see the two different components. One is actually representing the drill. The other one represents the machine. So this component represents the machine, which we can basically set the RPM, and you can set the geometry of that machine. And it's very useful when you want to create a robotic toolpath, because the robot does not, obviously, they don't come with the end effector. Then you have to buy your mill and set it up in your robot. And this is where you can set that geometry for the mill and also the plane of the tool tip or of the TCP, the tool center point. And also you need an ID in order to identify the tool in your robot tool library. Right now I'm going to ignore this. I assume that we're going to create a toolpath for a CNC machine, which we require only to set a milling tool or a drill, and this is where you can set your drill setting, the diameter of the drill, the total length, and then the effective length. The effective length is essentially the length where the drill can engage with the material, and that's obviously less than the total length of the drill. So I just consider something like 40 mm. And you can also right click on these sliders and set the value precisely. So the next thing you want to do is to provide a drill with a tool holder. A tool holder is essentially a device that holds the tool and attached to the machine. They typically look like this, kind of cylindrical. So they're all solids of revolution, meaning they're a result of revolving a profile about an axis. And what we need to do here, because this component just accepts a bunch of numbers, we need to provide the coordinates, 2D coordinates of the points on the profile that are important. And this geometry is used for collision detection, so it's going to change some of these milling strategies later on here. So they really depend on the tool holder at some point. And it also shows in the preview, so we can see how the tool moves on the toolpath. So in order to translate this geometry to a set of coordinates, we're going to start from the bottom of the tool holder. Well, the tool holder is attached to the machine, and then we go upward, and then we set the points where from the profile where they are important to us. So let us say I'm starting from this point down here, and I go up a little bit and go outside and then go up a little bit and then come back here, maybe less than what I went outside, and then I go all the way there, and this I assume would be the center of the tool holder. Um, so this is a sketch representing the important features of this tool holder. And notice I just ignore this reveal here because it won't really matter for the algorithms that are responsible for toolpath generations. So we can basically escape those tiny details, and also here and all other details. And now we have to really precisely calculate these coordinates with respect to well, I assume this would be my axis of revolution, and this would be my 0 point over here. Just put a point in the um, intersection. Okay, so uh, I consider that as an origin, and then I start placing coordinates in x and y direction, and the x will be the radius of that profile in that particular height, and the y would be the height of that point. So for instance, this point will be something about 30 millimeter, let's say, and 0 height. And then the next point is going to be the same radius, which is 30, and maybe something like 35 millimeter height. I just write this so we can refer to them later. And this you have to do it in your lab with the proper measuring tools. So I'm gonna do that. And by the way, some of these profile comes with the file that basically contains those information. So you don't have to really do anything, just to sort of transfer them to the Grasshopper. So we say 30 here. Okay, so this is actually the 30 in the radius, and let's say 0 in height. So to speed up the video, I have just created a bunch of coordinates here, as you can see. And now we're going to transfer them to the Grasshopper and then add them as a holder to our drill. I need a little bit of space. And then we're going to have a panel with the multi-line data. So the way we're going to enter those numbers here is that we start with the radius, and it follows with the distance from the previous point in y direction. So we're not going to enter the heights as they are, but we're just measuring how far we travel in y direction from the previous point. So that's very important. Please remember that. So the first radius is 30, and then of course the first point is always 0 in terms of the travel distance in y direction. The second point stays the radius 30, but then we travel 35 from previous point. The next point is 60 in radius, but nothing in y. And then we go to the 60 radius. Again, we stayed at 60, and we actually, I think we're traveling 30 here. And then we go back to 40 in the radius, and we stay on the same line. So 0 in y direction. And let me see what's the last number here. So the radius changes to 20, and it's 65 from the previous point. And then the last point is actually, this is not important, but we enter it. That's fine. So let's say 0 and 0 because the radius is 0 and there is no movement. So that's why I said it's not important to enter this one, but we can have it. Now, if you connect that to your tool, you should be able to see in the viewport at the origin the geometry of the hole there. So this is what you can see now. This is a rough representation of your tool. Just going to hide this for now and hide my preview. So it should look like the geometry. So if it's not, then you probably missed something or the numbers are wrong. Now the last thing you want to do is to measure the total length of the tool, including the drill and the hole there. Well, that means you're going to go to your workshop, and I assume if this is when you attach the drill, let's say this is your drill somewhere here, and from this point you got like a effective tool length. All you need to do is to measure from the tool tip, so measure from here to the bottom of the tool holder, and that's the total length which you enter in here. So this is now 177, for example. And you can see already that the drill shows up in the tool holder. And we are done with the setting of our tool holder. Okay, this is it for this tutorial. I hope you understand how to set up your tool and your tool holder. And we're gonna see each other in the next video and see how we can use that tool and produce some toolpath. Thanks for watching and see you next time.